Good morning students. So welcome back. So last time we have studied the fifth topic, number line. Today we are going to study the sixth topic, divisibility. When a number is completely divided by another number, we say that the number is divisible by that number. In other words, we can also say that the number which completely divides that number is the factor of that number. Right? Then one more thing. The digit in the units place of the product of two numbers is the same as the digit in the units place of the product of the units place digits of those two numbers. So what it means? For example, suppose I have got 29 into 37. So 7 9s are 63. 6 carry on. 7 2s are 14 plus 6, 20. 3 9s are 27. 2 carry on. 3 2s are 6 plus 2, 8. So 3, 7, 10. Now see this digit. What it is? The digit in the units place of the product. What it is? 3. Now, what are the digits here in the units place? 9 and 7. So multiply them. So digit in the units place, what it is? Let us see the product. 9 7s are 63. So what is the digit in the units place? 3. That's what it means. Okay. Then let's go to the next point. Suppose if a number is multiplied many times, then it is found that it repeats itself after regular intervals. Means, for example, if I multiply 1 time, you will get 1 in the units place. If I multiply 2 times, what I will get? 1 into 1. Again 1 in the units place. If I multiply 3 times, 1 into 1 into 1, what I will get? 1 only. So carry out, you will always get 1. But suppose if I go for 2, digit is 2. If I multiply 1 time, 2 1s are 2. Units place 2. So when you multiply 2 once, you get 2. If you multiply twice, 2 into 2, 4. If I multiply thrice, 2 2s are 4, 4 2s are 8. So units place 8. If I multiply 4 times, 2 2s are 4, 4 2s are 8, 8 2s are 16. So units place 6. If I multiply 5 times, 2 2s are 2, 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. Units place 2. So what do you get? 2, 4, 8, 6. And fifth time when you multiply, you get the same digit. You can see. So it repeats after regular interval. So this is for 2. Digit 2. If I go for 3, 3 1s are 3. 1 time. If I multiply 2 times, 3 3s are 9. If I multiply 3 times, 3 3s are 9, 9 3s are 27. Units place 7. Okay, if I multiply 4 times, 3 3s are 9, 9 3s are 27, 27 3s are 81. Units place 1. If I multiply 5 times, 3 3s are 9, 9 3s are 27, 27 3s are 81, 81 3s are 243. Units place 3. So you can see 3 repeats itself again. So again you will have 3 9 7 1 3 9 7 1. Same here, 2 4 8 6, 2 4 8 6, and so on. Do you get it? So that's what it says. Same way you can check for 4 5 5 5 5s are 25. 2 times. 3 times 5 5s are 25, 25 5s are 125, so 5. 4 times 5 5s are 25, 25 5s are 125, 125 5s are 625, again 5. So if you go and multiply, you will always get 5 only. What about 4? 4 1s are 4. 1 time 4. 2 times 4 4s are 16. Units place 6. 3 times 4 4s are 16. 16 4s are 64. Again 4 is repeated. 4 times if I go, 216. So 6. So 4 6 4 6 4 6 4 6. Right? 5 I said 5 5 5 5 5 5. If I go for 6, just the same case. 1 time 6. 2 times 6 into 6, 36, 6. If I go one more time, 3 times. 6 into 6 into 6. 6 is 36, 36, 6 are 216. Again 6. So all 6. And 7 if I go. 1 time 7. 2 times 9. 7 7s are 49. 3 times 49 7s are. Right? So 7 9s are 63. 3. So you can see exactly opposite of this will come. Okay. 7, 9, 3 and then 1. And then again 7, 9, 3, 1. And if you go for 8, it will be 8, 4, 2, 6. Exactly opposite of this. 8, 4, 2, 6. Okay. So in that way it will go. And for 9, 9, 1, 9, 1, 9, 1, 9, 1, 9, 1 and so on. So in this way you should know this, how the digits are being repeated. Now you know that operation of division, that is dividend is equal to divisor into quotient plus remainder. We know that. We have studied right from 3rd standard. Okay. Now test of divisibility. Let us study some of the tests for divisibility. I know you know some of them. So what is the test for divisibility by 2? Yes. If in the units place of a number digits like 0, 2, 4, 6 or 8 is there, then that number is divisible by 2. Right. Then test of divisibility by 3. If the sum of the digits of a number are divisible by 3, then that number is divisible by 3. Test of divisibility for 4. If the last 2 digits in a given number are divisible by 4, then that number is divisible by 4 exactly. Then 5. If in the units place of a number there is 0 or 5, then that number is divisible by 5. Test of divisibility for 6. If the given number is divisible by 2 as well as 3, then that number is divisible by 6. Yes. Then test of divisibility by 7. Now this is something different. Okay, what you are supposed to do? Suppose this is the number 752. I don't know whether it is divisible or not. So what do? Choose the last digit. What is the last digit here? 2. Take twice of it. So 2 2s are 4. Subtract this from the remaining number. So 75 minus 4. What it is? 71. Is 71 divisible by 7? No. So this number is not divisible by 7. You can check it over. 7 on the 7, 0. 5, 52. 7 7 is 49. 7 8 is 56. 52 does not come in the table of 7. Okay. Another number we can take. Suppose if I take 126. Now 126. What is units place? 6. Double of that. 6 into 2. 6 2s are 12. Subtract 12 from the remaining number. So 12 minus 12. What it is? 0. Yes. You got 0. And then once you got 0, that means the number is completely divisible by 7. Do you understand? Okay. Now, I will take one more bigger number. Okay. For example, suppose if I take 26,502. 26,502. So units place 2. Double of it. 2 into 2. What it is? 4. So 2650 minus 4. Subtract that number from the remaining number. Okay. So 10 minus 4, 6. This becomes 4. So this is 10. This is 4. Right. So 2 6 4 6. Now units place we can't decide. So continue further. Continue further. So 6. Double of 6. 6 2s are 12. So 264. That is the remaining number. Minus 12. So 4 minus 2, 2. 6 minus 1, 5. 252. Yet I can't decide. If you cannot decide, you can go further. I know that, but for your understanding. Okay. Now double of this. What is double of this? 2 into 2. 4. Subtract it from the remaining number. 25 minus 4. What do you get? 21. And is 21 divisible by 7? Oh yes, it is divisible. That means, is the number 26,502 divisible by 7? Yes, it is. And in this way, you can use the test of divisibility for 7. Okay, 8. What is the test of divisibility for 8? If last 3 digits of a number are divisible by 8, then that number is divisible by 8, right? Then 9. 9, simple, just like 3. Sum of the digits. If it is divisible by 9, that number is divisible by 9, right? Then 10, simplest. If 0 is there in the units place of a number, then that number is divisible by 10. 11, if the sum of alternate digits, even and odd, the difference between them is 0 or multiple of 11 or divisible by 11, then that number is divisible by 11. Okay, let us check it. For example, suppose I have got this number 11,979. So what I say, sum of odd places and sum of even places. So this is 1, 3 and 5 odd places. Okay, so 1 plus 9 plus 9, how much? 19. Now which are left? 7 plus 1, right? So 7 plus 1, how much? 8. The difference, 19 minus 8, how much? Yes, exactly, 11. Now is 11 divisible by 11? Of course it is divisible, and hence the number 11,979 is divisible by 11. Yes. Now test of divisibility for 12. What it is? If the number is completely divisible by 3 as well as 4, then that number is divisible by 12. Same way for 15. If the given number is divisible by 5 as well as 3, then that number should be divisible by 15. Basic, if you know, it's okay. Okay, 2 to 12. Bas ho gaya. Okay, then, now let us move further. Let us solve some examples based on these tests of divisibility. Okay, so exercise 6, there is only one exercise, so I am going to solve some of the examples, not all. Okay. So second one, exercise 6, second one. Exercise 6, number 2. What is that? How many integers from 700 to 800 are completely divisible by 7? Okay. So first find out the first number. We are going to use this formula. Tn is equal to a plus n minus 1 into d. So I need a, that is the first term, t1, and I need the last term, that is tn. I know the common difference. Common difference, all are divisible by 7. So difference is of 7. Here d, that is common difference. We have used this formula last time, if you remember. Okay, so common difference is of 7, right? First term a, what it has to be. So 707, obviously. Okay, so that is the first term. If I am not wrong, you can check it. It has been said how many integers from 700. So from 700. So 700 is the first term. Okay, so 700 is the first term. Do you get it? Now last term, that is Tn, I need to find. How to find Tn? Divide 800 from 700 to 800. So divide 800 by 7. Let us see what happens. 7 1 the 7. Remainder 1. 10. 7 1 the 7. Remainder 3. 30. 7 4s are 28. Remainder 2. Now subtract this 2 from 800. So 800 minus 2, that is 798. So this is the last term, 798, which is divisible by 7. You can check it. 7 1 the 7, 9. 7 1 the 7, remainder 2, 28. 7 4 is 28. Do you understand? So this is the last term. Now I know A, I know Tn, I know D. Can I get N? Of course I should. So Tn is equal to A plus N minus 1 into D. So Tn is 798. A is what? 700 plus N I don't know, minus 1 into 7. So what can I do? Bring this 700 to this side, it will become, yes, obviously minus. So 798 minus 700, that is equal to N minus 1 into 7. So 798 minus 700, how much? 98. That is equal to N minus 1 into 7. Divide both sides by 7. Okay, so you get 98 upon 7 is equal to N minus 1. So 7 1 the 7, 7 1 the 7, 2, 28. 7 4s are 28. So 14 is equal to N minus 1. Bring this 1 to this side. So it will become plus. So 14 plus 1. So that is N. So N is equal to 15. So option number third. So how many numbers are there? 15 numbers are there. So option third. So there are 15 numbers which are completely divisible by 7. From 700 to 800. You can find out the numbers completely divisible by 8 from 800 to 900. Try this. See how many you get. Okay, in the same way. Okay. Now, so now I will solve fourth one. Okay. Now fourth example, it is asterisk is equal to a circle with dot plus 1. As per this condition, which of the following digits should replace asterisk in the number 3 asterisk dot 5 so that it is exactly divisible by 3, and you have to choose two alternatives. So first option is 9, second option is 7, third option is 5, and fourth option is 1. Now what it is said? You have to choose, you have to find, replace asterisk by one of these digits. Now one thing you should know, that this is equivalent to this symbol plus 1. So if I want to find the value of this, what I should do? Subtract 1 from this. So any digit, suppose if I take 9, if asterisk is 9, so for first option I am going 3, 9. So if asterisk is 9, so what will be that symbol circle? Minus 1. So that should be 8. So 3, 9, 8, 5. Do you understand? Okay. So let us check sum of the digits. 12. 9 plus 3, 12. 12 plus 8, 20. 20 plus 5, 25. Sum of the digits is 25. Is it divisible by 3? No. Then second one, 7. Now if I take 7, so circle should be 7 minus 1, 6. Yes. So 3, 7, 6, 5. So sum of the digits. Test of divisibility for 3. 7 plus 3, 10 plus 6, 16 plus 2 plus 5, 21. So is it divisible? Oh yes, of course. 6 plus 5, 11 plus 7, 18 plus 3, 21. So it is divisible by 3. So second option is correct. That is one option. We have to find one more. So third. Suppose if I take asterisk to be 5. So 5 minus 1. Okay. That will be the symbol of circle. Value of circle. Okay. That is 4. So 3, 5, 4, 5. So 3 plus 5 plus 4 plus 5. So 5 plus 3, 8 plus 4, 12 plus 5, 17. No. So 4 plus 5, 9 plus 5, 14 plus 3, 17. So it is not so. So we know that the fourth one is the correct option. But let us check it. Okay. Let us be on the safer side. So if asterisk is 1, what will be the circle? 1 minus 1, 0. Right? So 3, 1, 0, 5. So 3 plus 1 plus 0 plus 5. 3 plus 1, 4 plus 5, 9. And yes, 9 is divisible. So option number 2 and 4. That is the correct answer. Okay. So let's move to the next example. So now sixth example. Fifth we have done last time. So you can do it. Okay. Sixth example. Same digit occurs in the place of asterisk in the number 950 asterisk 2 asterisk. Okay. If this number is divisible by 11, find the digit in the place of asterisk. Okay. And the options given are 8, 6, 5 and 3. Okay. 8, 6, 5 and 3. Now, test of divisibility by 11. Yes, so let us check for first option. That is 950. I have to take 8 to 8. Then what we should do? Find the sum of odd and evens. Right? So, here like this. Right? And here like this. Okay, so 8 plus 8, 16. 16 plus 5, 21. Right? 21. And here 9 plus 0 plus 2, that is 11. And 21 minus 11, 10. Is it correct option? Is 10 divisible? No. So this number is not divisible by 11 and hence it is not the correct option. Then second option, what it is? 6. So 95062 Again the same method. Well, here, then this, right? So here 5 plus 6 plus 6, that is 6 plus 6, 12 plus 5, 17. And here 9 plus 0 plus 2, that is 11. Now 17 minus 11, how much? 6. Is it divisible? No. So this is also not the correct option. Now third. So 950525. Again the same method. Right? So 5 plus 5 plus 5, that is 15. And here 9 plus 0 plus 2, that is 11. Now 15 minus 11, how much? 4. Is it correct? No. So last option. Obviously that is going to be, that has to be. Okay, so fourth option, 950323. So let us check. Okay. So what do you get? 5 plus 3 plus 3. So 5 plus 3, 8 plus 3, 11. And 9 plus 0 plus 2, that is 11. And 11 minus 11, yes, 0. So correct option, option number 4, right? I know you are going to draw the circles and you are going to shade them. Okay? Have that habit. Because otherwise if you don't have that habit, then it becomes problematic. And use always ball pen only. Don't use gel pen or ink pens because that spreads and it will spoil your answer sheet. So take care of it. Okay? Now let's go move to the next example. Now example number 8. Which of the following digits should replace star in the number 3 star 878 so that it is divisible by 7? Again, choose 2 correct alternatives. Okay, so let me write the number first. I am solving 8th one. 3 star or asterisk 878, and this has to be divisible by 7. Options are 1, 4, 7 and 8. So test of divisibility, right? So I have got 3 asterisk 878. What is in the units place? 8. 8 into 2, 16. Subtract 16. 8 asterisk 8 7 from the remaining number. Okay. So what I get? 7 minus 6 1. 8 minus 1 7 asterisk 3. Am I right? Yes. Now units place 1. Double of 1. 1 into 2, that is twice of 1 is 2. Subtract 2 from the remaining number. 3 asterisk 7 minus 2. What I get? 3 asterisk 5. Okay. Now 5 twos are 10. So I have to subtract 10 from this number. So 3 asterisk minus 10. I should get here the number which is divisible by 7. So let us check. So suppose if I check first option 31. In the place of star I am taking 1. So option 1. Okay. So 31 minus 10. How much I get? 21. Oh yes! That is the correct option. Right? Because 21 is divisible by 7. Right. Then next I can take 3 asterisk. Asterisk I am taking 4. So 34 minus 10. What I get? 24. Is 24 divisible by 7? No. And so that is not the correct option. Then third. What is that? 7. Right? So 3 in place of asterisk it comes 7. And 37 minus 10. What it is? 27. Is 27 divisible by 7? No. And so that is not the correct option. So definitely, obviously, fourth option is the another second correct alternative. Let us get it confirmed. Right? So fourth option. 3 in the place of star I will have what? 8. So 38 minus 10. How much? 28. And so option number 4 is also the correct option. So option 1 and option 4. So 2 circles you are supposed to shape. Option 1 and option 4. If any one of them you forget, you get 0. You don't get half mark, 1 mark. You don't get 1 mark because one option is correct. Not at all. Both have to be opted. If both the circles are shaded, then only you will get full credit. Otherwise 0. Okay. So let's move to the next example. So now example number 11. By which of the following digits should star be replaced in the number 3271 star so that the number will be divisible by 2 and 11. So what is the number? This is example number 11. Okay. 3271 star. That is asterisk. Okay. Now it should be divisible by both 2 and 11. Okay. Now options are 0, second 2, third 4 and fourth 6. One thing I would like to tell you. If you see all these digits, they are 0, 2, 4, 6. So any one of you take here, it is always going to be divisible by 2. So the only question is to decide whether it is divisible by 11. Okay, so what can we do? See here, what I do now. 3, 2, 7, 1 star. So go for the odds and evens. Right? So 3 plus 7 plus star. And the next is 2 plus 1. Am I right? Now this is 3 plus 7, 10. 10 plus star. And this becomes 3. So I have to choose here a digit in such a way that when I add them, difference of these two I should get in such a way that it should be divisible by 11 or it should be 0. Okay. Now 0 is not possible. So it should be divisible by 11. So suppose if I take 0, what I will get? First option, 10 plus 0. I am just showing you. I know directly I can do it. Okay, but for your understanding I am going option wise. Otherwise directly I would have put the digit here. Okay, because here, see here, 4, 10 plus 4, 14, 14 minus 3, 11, finished. Okay, so that is divisible. Now 10 plus 0 is 10 and this is 10, 3, 10 minus 3, 7, not divisible. So option 1 is wrong. Option 2, 10 plus 2, that is 12 and 12 minus 3, 9. So again it is wrong. Okay, third option, that's what I said, 10 plus 4, 14 and 14 minus 3, 11, and so that is the correct option, option third. Do you understand? Okay, so no need to go for the next option, only one option is correct. Okay, so then last example, 13. This was asked in 2018. There is nothing to solve, just we have to discuss. Read the following statements and choose the correct alternative. The numbers that are divisible by 6 are completely divisible by 2 and 3 also. The numbers divisible by 15 are divisible by 3 and 5 also. 600 is completely divisible by 2, 3 and 5. And what are the options? Only A is correct, only B is correct. All the three statements A, B, C are correct. And fourth, all the three statements A, B, C are incorrect. Now let's go statement wise. First, numbers that are divisible by 6 are completely divisible by 2 and 3. I've stated that test of divisibility. If a given number is divisible by 2 and 3, then it is divisible by 6. So that is correct. Right? Then second, the numbers divisible by 15 are divisible by 3 and 5 also. I have given the test of divisibility for 15. If a number is divisible by 3 and 5, then that number is divisible by 15. So this is also correct. Okay. Then third, the numbers divisible, third, 600 is completely divisible by 2, 3 and 5. Definitely. 6 comes in the table of 2, yes. In the 3, yes. And in the units place there is 0. So it is divisible by 5. So it is divisible by all of them. Okay. And so from that what you can say that all the three statements are A, B, C are correct. That is option number 3. So dear students, solve the remaining examples as homework. If there is any doubt, definitely you ask me. You are most welcome. Okay. So let's meet in the next period. Till then, goodbye. Thank you.